virtual machine hosts pretty much anything. The Docker is a software implementation of a software for, that's the container software for initially in Linux, but later for other platforms as well. By the way, there was a quiz this morning. For those who came in late, I will announce it again at the end of the class. So, you can take it. For the virtual machine question, if you want to do it again, for those who have taken earlier, I can allow you to do that. So we are not going to talk about the more details about Docker, but Docker is an now very popular service on all the public clouds, and I mentioned that it's all the commands are based on. It looks like a Linux just starts with the Docker container, right? If you have, so suppose you have this even virtual machine as well. I cannot let this up. So you have a thin hypervisor, at least it does the interface between the virtual machines and hardware. Now you have a container engine that does interface between containers and the host OS, right? So you have that basic mechanism, but what do you think? Is that it allows the basic operation of what we intended, which is a running containers, right? But and also virtual machine as well. But you would soon run into or realize the problem, run into issue or realize the problem that, well, if I have a lot of virtual machines, I want to be able to manage it better. If I have some application that does needs more scaling, the automatic scaling up and down, up or down, and maybe you want to be able to migrate the containers, migrate virtual machines, and you want to pause, start, stop, all those things. The start and stop, it should be basic the commands for the hypervisors or container engines, but you do need more than that as you run more applications on top of it. So what it means is that it calls for the need of management tool, orchestration tool for containers and also for virtual machines as well. And there has been some, and then they find that some issues or we think we can do better than that. There are different communities or different group of people come up with their own solutions. So there has been actually a lot of orchestration tools available. The Docker Swarm is the initial one for Docker case. Kubernetes, you probably have heard of it. Now it's another very popular one for container orchestration. So Docker Swarm, container, the Kubernetes, all those names. What are they? What do they do? They do container orchestration management. So what it does is that deploying new container following certain image and pods, migrate, add more, delete some. So these are the purposes. That's a very important purpose for managing new the platform or / infrastructure resources. So for now, just know that what is a Kubernetes, what is Docker Swarm? Those are container orchestration software tools. Kubernetes, think about how to, so this is called Kubernetes. Can you spell those? I cannot work this out because it's a PDF. Kuber, Nets. How many letters are there? 10. So K8S that's an often acronym, often name because it's too long to write down. Yeah. So you might see, KDS.com something. So what it does is that it does container orchestration. Uh, so there will be a lot of containers being built for some application services. These will be called pod, right? Uh, in a P, it's a cluster. So it's a cluster management. Yeah. So you see that hey, there are now a lot more. Okay? So not just Docker Swarm, Kubernetes, but there are many others. Your purpose is never to master all those, but if you, at least you should, in this class, at least the purpose is that what are these, and they're having a big skeleton, you know, the not considering everything as an equal. We know that there's an infrastructure. Now we have a container platform, and there is a need for a management tool for those, and Kubernetes is an example. Okay, so that, and then later for your projects, per, perhaps and in the future in the industry as well, depending on the need, you make decision which one to use and be able to use that. That's it. You may see mesos. This is what initially UC Berkeley and Princeton University, they work together, and all those things, actually academia started first, and they had it started up. Also, they made it really, made the source as an open, so it really contributed to the community. You will see mesos often still now in the big data analytics or cloud, the ecosystem stacks. So again, some of the names: Kubernetes, OpenShift, Dataflow, mesos. Those are the things you can know, and GitLab is one of them as well. And of course, the public cloud will have that one as well. So let me stop the on Docker for this slide with this slide. We called it. We have an exam next Thursday. So another announcement. I think you have probably seen that there is a trier exam with the Respondus Lockdown browser. So you have to install a Respondus Lockdown browser. That's a browser, but from that browser you go to Canvas, you find our course. That's how the exam will be. And once you log in, actually once you start that out, every other program has to be closed. You cannot do internet browsing. And I want you to have just, the testing. You don't want to waste your exam time for that, right? And I need to download the Respondus Lockdown browser and need to set up, do it in advance. Right? So there is a trier exam, and I think, yeah, I believe so. There will be at least a couple of questions that will be for sure in the exam as well. Those are the two questions that you come up with on your own. So, these the graduate course topics can be it's an open topic, right? And assuming within at least the topics that we have discussed in the class, if you want to go into deeper, I do encourage you to do that. And I may not ask that one in the exam question, right? So that's the opportunity for you to show off your knowledge in the topic that we have discussed within the class. So occasionally I do see exam questions that you come up with on your own about, say, network virtualization, software-defined networking in the exam one. That's irrelevant. I would say. Okay, so within the topics that we have discussed so far today, so far up to the exam, that includes all the, the overview, virtualization, containerization, serverless computing, and Linux as well. So only the topics that we discussed in the class. Within those, you can go deeper, or it has been discussed in the class, but I didn't ask you in the exam. Then that's the topic that you can write about, right? So yeah, I want you to think on your own. Yes.
Is it going to be the MCQ or we
So
need to?
both, one multiple choice question, one descriptive question. And multiple choice question, you should have at least three or more choices. Cannot be true false question. Descriptive question, again, so the first question I will ask you is that, define cloud computing in your own words, and you cannot do the same question, the multiple choice as well. So just like the same, practically it's the same question, slight change of the choices, that doesn't count. So that means that you don't know what I'm going to ask, right? The that it will be not too different from the quizzes. Maybe a little, maybe some questions may go a little deeper. But anyway, since the questions are not known in advance, that means that you have to consider preparing multiple questions, right? The things you have got in mind, and I asked a question, you might say, dang it, I have no question to write about. But don't let that happen. Okay? Other questions, comments? Okay, so the Docker Swarm commands, those things I'm not going to ask you in detail, but you can actually do that. And what is it? At least you should know. So far we talked about whole machine virtualization, and then lightweight virtual machine containerization, and now we're going to talk about the serverless computing. In assignment 1, you have read 2 articles, one from 2009, the other one is from, remember, 10 years later. That's a hint. 19. Okay. So the Randy, the set of, I know multiple Randys. Yeah. So suddenly I blanked his name. The Not Randy Pausch. Well, we talked about him many times anyway. The set of the professors at UC Berkeley talked about the future of the cloud computing in 2019, and the core was about this serverless computing, right? So the title was the rise of serverless, right? The serverless was rising 2020 or later. It's just a very short period. It has become very popular, and all the major public cloud service providers offer serverless services. And they are named a little bit differently. Some the provider will say lambda, some provider will say function, and this is open source, right? So you see that as a common is a lambda and function. So when you see those services, you should know that's a serverless service. Okay. So what can you make of from these lambda and function? What is what implication do you get? We are still in the topic of the server computing virtualization, right? So the machine lightweight virtual machine, and then serverless. That's how we are progressing. So the the first impression you probably will get from the word lambda is what? Something, sorry, something,
Lambda architecture.
lambda,
Yeah,
right. So, I
the
mean,
live streaming data to the processed data.
okay,
I
right.
remember Lambda.
So a lot of things
Yeah.
actually, when big service is done, some component will be done through Lambda. So let me give a really easy multiple, well, true false question. Lambda, do you think is something big or small? Small, right? So that's what it means. Function, something, it's a module within the procedure or program, right? So just like that, the serverless computing, it means some, it works as a module, it works as a small module, right? That's what it means. Think about the network. So the the web server assignment, right? The For a web server to be accessible, there should be a program running. HTTP server-side program should be running, right? So that HTTP client side, which is a browser, make a HTTP request over the network, even though they are running on different OS machines, they can still communicate with each other because they speak the same protocol, right? So program has to be running, and that program should run on some computing resource, right? So, but you didn't really allocate a machine. You didn't allocate a container. You just did click, 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 right? So, but assignment 3 will be very different now. So part of the purpose is that appreciate the assignment 2 approach. Assignment 2, we call it the cloud provider managed service. So that means that there is a server, the program should be running, but the program or the function is managed by the cloud provider, okay? Not by users or developers. So the serverless computing, actually it means that it should be a server. Serverless computing doesn't mean that there is no server at all. It's completely different software architecture. That's not the case. Peer-to-peer architecture, still there is a client and server. Just the peer node runs both server side, the client side of the protocol and program code, right? That's what it means. So the provider manages all those allocating a resource, running that HTTP server on behalf of the users. It's managed. They do all the management for you, developers or users. That's good for you, right? If you have to do it yourself, like you were gonna do in assignment 3, virtual machine, you have to do a lot of things. You have to install software, install HTTPD or the whatever server-side program, and you have to configure it. And that's a snapshot. But if you are running it for a long time, you will have to do a maintenance upgrade. Also, hardware issue you have to consider it. Network issue you have to consider. So software server in general does require a lot of work of maintenance. The maintaining servers, it's a big portion of the pie of all the overhead. Okay, so developing a service, having a steady website, done. Um, that's only part of the big picture. Server to install, run, and maintain it. There are lots of overhead. So cloud provider, well, this is opportunity for me. Let's make things easier for our users. Let us manage it for them. So that's the manage the service by a cloud provider, and from the user side, it looks like a serverless, but in reality, it's not that there is no server at all. Okay, so this is the new type of service that cloud provider, and this is a function. So whenever user need a web server, whenever user need a database server, or some data processing parsing server, they cloud provider launch it and run it for the users. So that is the packaged as a name service or function as a service. So in fact, Lambda, this is a program code function, right? So this is a function as well. These are all familiar names for us, the CS folks. Maybe for non-computing folks, this might look a little, not so easy for them to understand. So people might say, the CS people are making things complicated. But in fact, nowadays, coding is becoming really pretty, becoming universal. So I see that even Walmart, just regular job opening announcement, advertisement, it's all done with the like a code-like thing, right? So yeah, you can have this input with a Walmart in it, the outcome will be happiness, things like that, right? So what do you think? So when a cloud provider run the web server using their computing resource, one option is that they can use they launch a new virtual machine inside it. But user side, especially network program, OS doesn't matter as long as it speaks the same protocol, right? So in practice, what do you think between virtual machine and container? Which one they are gonna use? Container. So my questions are maybe too easy for you to answer. So it's no trick question at all. So please feel free to say the other question. They run those functions in a Linux container on events whenever needed. Right? So not like allocate pre-running everything, but whenever there is a special event happening that does need those services, then provider will launch this service. It can be used for web applications, IoT applications, like when temperature is higher than something, then notification is pushed in like that. The stream processing, right? A lot of the parallel, computation. When there is a more need, the more parallelism or less parallelism, those adaptation may be needed. Those applications or video encoding, this is you don't need the machine for all the time, only beginning or decoding at the end, right? So think about all these applications. It makes a good sense that you run that service done by the provider whenever you need it, and this is not necessarily permanent tasks. Web app is a permanent, but there are a lot of different small components that needs to be triggered per events. And static web app, they can also make it things easier for users upfront, just like having cloud services offered by them. So all these applications, it's a good case for the cloud provider, providing services, new revenue generator as a serverless function. For comparison, with a serverless architecture, you don't have to do server setup and OS management. The scaling will be easier, availability is higher in a sense that the voltage is higher, we need more. That can be added automatically by the threshold or whatever parameters. The no idle capacity is almost like we said that virtual machine. It's great, isn't it great? We don't have to purchase. We don't have to order a machine, install a machine, put it in on a desk, and power it up. We can just virtually, whenever we need it, launch it. So I was glorifying virtual machines. But think about some small network applications that are only necessary for the uh, the certain period of the time, and very small program like HTTP server as is, not other database together, just a single HTTP server. That's all you need, like assignment 2, right? In that case, if you have all the virtual machine installed, and there might be only 2 inquiries, that for your testing and maybe today's testing, and maybe my testing as well. So then the whole virtual machine is being wasted, right? So if you consider that smaller micro scale, the virtual machine, it wastes capacity. And with a serverless, make it happen, managed by provider, and then you will be only charged whenever there is a click for the operation of the server. So that's the serverless architecture. It can really useful for using the resource more efficiently from the cloud provider side and also user side. You don't have to pay for unused one. Under provisioning, over provisioning, you don't have to worry about. We use the same word for virtual machines, right? But now you know the context. We are talking about the provisioning in terms of virtual machines. So in comparison, you have to do all this management, the maintenance operation on your own. So you see so with all this, it's faster time to deployment and market. You know that assignment 2, it was easier, right? Things are getting easier and easier. Are you scared, or is it easy for you? Good for you in some sense, but for your job security, the other people who, without computer science background, they can do that too. But that means you have to understand really behind the scene. And a lot of companies, they are doing private cloud. So, not just the majority of at least the jobs that you are going to find is a place where they do it on their own. Right? So this is another way of doing it. Web server, there will be, whatever showing part, running HTTP server part, and then behind it there's kind of database server. With the serverless architecture, whatever interaction with them, the HTTP server is gonna run as Lambda or microservice. And then there will be the database layer as well. And this can be also run as a Lambda, or if it's a more persistent one, it can be VPF. Yes.
So the serverless architecture only appears to be serverless, but it isn't actually serverless.
Exactly. That's a summary of what I have said so far. So serverless architecture, it doesn't mean that there is no server at all. Serverless architecture, this is all serverless. If you only see that, it's only marketing articles. Technical articles, it should be there. Of course, there should be. If you understand HTTP, how the web protocol works, and how you do network program, you develop a network program. There should be a HTTP server program running. It has to run all the time. It's the definition of client and server. What is it? Server is always on, at least on before client contacts. Just like a brick and mortar store, Walmart, Best Buy, it's that at least 95 it is up, is open. Not the hour may not be correct. The So what do? Whenever you want, whenever you have a need, you visit there and purchase something you want. You are a client. Store is a server, up, always up and running, um, and it is well known. IP address is steady, well known, reachable, and then clients can come anytime when they want intermittently, right? So that architecture is always there. That's how the program works. Just that serverless for regular users, the high-end users, they who doesn't deal with the lower end, back end, they don't have to manage, um, worry about those the servers by themselves. That's what it means. So, yes, no question. Is serverless architecture? There is no server at all. No, there is a server, right? But it is not managed by the user. That's what it means. So if you really think about it, the decoupling of resource is a really clever and the amazing insight they have. Abstraction, decoupling, this is the theme you will hear later again and again in cloud computing in general and in computer science history. Right? Previously, computing means that CPU, memory, storage are all together. It always has to run together. Here, but it's how it works is a database separate, HTTP server computing that's a separate, and then it can run on a different machine and it can run on a different time. And then the user can run application without managing resource allocation, and also just like the cloud computing initial the explanation, users pay in proportion to the resource they have used. So when something happens, like user clicking on, so for example, in the commercial website, user clicks on the credit card, the payment button. That's a special event that triggers the credit card processing server, and it might have to check with the database behind it. So really, this is an event triggered application running. And if this one can work with anything, any other thing, it can be database, it can be other services, other streaming, the processor after process. So there are already commercial as well as the open source the platforms available. As we have seen before, Lambda, Google Cloud Functions, Azure Functions, IBM Functions, then the Apache OpenWrite, the FM4 functions, right? So once you have this understanding, you can some other provider, some function or some Lambda, you can immediately find that this is a even lighter weight service that can be run on a container by the cloud provider. Right? So in 2019, they talked about, in the article you have read, they talked about this is going to be big. They were projecting it, right? It was not yet that popular at that point of time they offered by public cloud, the various forms. So around 2017, 16, and a few years later, there has been a lot of research. The how it can be done, and some of the offerings that is already available, how do they perform comparatively, and also what are the problems there, what are the limitations there. Whenever there's a new service, you can imagine that those can be immediate researchers' questions in the research topic. So there has been some of the slides, in fact, come from those papers. So serverless application, when you write an application, there will be some flow and some conditional flow of the functions operations, and you will need a different portion of the program as it progresses, and you can make the resource allocated by the cloud provider depending on the running of the execution flow. That means that each function or lambda is going to be executed on what condition. That's as a developer, you have to consider the composition flows. So these are the things that you might consider as a developer for your applications developing. You might want to have a sequence of functions, some functions in parallel, some functions based on the value of the data, and maybe the rerunning of the functions, and special conditions, the exception handling, and you can also bring some time frame of the function operations. All these developers planning, you can do it with the cloud service functions. You do it all the time in a small code, like even the adding data or some processing data, you can think of all these questions. And now in bigger network application, you can think of it as running servers in sequence, running some servers in parallel, running some servers based on the data. Like once you click on some item on Amazon, based on your click, there will be other processing and recommendation will follow. So all these the coding questions, now you think of it in a bigger scale as in a service level. So there has been a lot of papers around 2017, 18, 19. It's just a few years ago. Just like a container and virtual machine, whenever the first thing happens, the set of questions that followed later was orchestration tool. And you can also think about it here too. You need a better orchestration for serverless workflows. You need a better way to compose and reuse functions. We don't yet have the rails of serverless, the management tools, something. So what it means is that when serverless idea, the concept was introduced, there has been some offerings, introductions, but still at that point of time, researchers or engineers, scientists could find a lot of issues there. That means that people were starting to looking into and provide ways to do things better, right? Research will need to focus on what contribution models would be function as a service. So with all these questions were asked, and a lot of things has been produced. So part of this is one of the papers published in I think 2017. The serverless computing, they say it's a dilemma. It's hard to provide all three together. Actually, before I show this, you could actually think of some problems. You could think of problems. So here's a serverless computing idea, right? And then maybe next question, as you have seen, some good orchestration is necessary, right? In other words, orchestration is not easy initially, and now it's a lot better, but still there are limitations. Um, why there are limitations? I want you to think about it. And then any other question you can think of practically. When there is a program, big program, and you consider modules, and this module will be run by serverless computing resources. Any program, there can be a loop, there can be infinite loop. You might be built a lot, multiple times, or into too much, right? That could happen too. So exactly this, the researchers have seen the issue. The serverless function without the considering the detail inside much, if we want that to be used, and composition should be easy to do that in a nested composition as well, and no double building. We want that. We want the no double building or triple building will be happening, but it's difficult to provide all of them together, right? Especially composition of functions with the functions, function inside a function. So that's a loop. And how can you ensure there will be no double building, right? So this is a difficult thing to do and problem. But there are three papers that identifies a problem and solves it, and there are also there are papers that, like a position paper, this is a difficult issue, and listing out, several big picture questions, and this is the paper like that. So whenever you use a function, you have to be careful to whether how you are doing. Right? They might say, this is not an issue, but still, they might not have to test it. You might run into the cases they haven't expected. Right? Anyway, once we have the concept of the smaller module run as a server, then the application will need a lot of compositions, as we have said before. The combining multiple functions together, making it a bigger function fusion. Later I will have a case, or you can think of a case, what kind of operations can be possible, fusion is possible. And then coordination, depending on the condition, it might be running different functions. And function may be changed depending on, it's a sequence of the operations. And also, depending on the event, different functions can be triggered. And maybe we can consider the bigger workflow can be designed through functions. So functions is a small serverless, small things. You don't have to do all things. They know, cloud provider know what kind of functions that user might do, like web server. So they provide the services. Initially, the web, like a Google site, they didn't have that before, but this is something that user want to do a lot. Maybe let's make it as a the serverless computing service. So that's how they operate. So the well-known or the popular the module services, they make it as a service. They make it as a service, serverless computing as a function. In fact, function is what do you think? Serverless computing is really misleading word, right? It is a server. So function actually that sounds more theoretically correct, right? Like you might, for non-technical folks, serverless is more catchy because what is a server? It's hard to manage it, and it is done by the provider. So, this is how the orchestration or composition can be made in these services. You look at this; it's like a coding, right? When these events happens, this is you start at phase one and next phase, so it's like a sequencing, right? You can also have a loop. This function, uh, you can have a loop of functions. So really, it's a programming in a bigger scale, right? You For developers, you think of a big picture, not really always focusing on C programming, like a pointer, what's the next character it is pointing to. Rather than that, it's really considering bigger application flows. You can focus on that. So that's what I said. The uh, Previously, developers might have to focus on all the within the function, how we implement those line by line, things like that. Now, um, developers can consider more bigger scale application itself. So this is another paper that talks about the so the serverless orchestration. It's a coding, and it may not be that easy. So what this paper was trying to do is that the paper is called the transpile, like a translation and compile, meaning that from the application code, they translate it into serverless orchestration code automatically. Isn't it cool? I mean, if you think about it, it makes sense, good idea, but before you have seen this, okay, suppose you just heard about the concept of serverless computing or function as a service, the concept. Then what will be necessary, and then you can think of orchestration tools, and then what could be the issues, like a double billing. You want to be able to compose the functions in any way, including loops. You want to do it, right? And also, what about the traditional code that is already done? How can I convert it into, the cloud service that uses the function as a service? And it will be good to have a tool that translates it, right? So it makes all good sense, but I want you to really appreciate those researchers, the early thoughts and effort. So but still you can also not just the appreciating and that's it, end of story, problem solved. Rather than that, you always have to think, how does it how well does it work? I want you to have those questions in mind. You're not really high end, non-tech user, right? So you have to have those questions. It might work in some well-known cases and maybe not in some cases. And these are the actually research work. If once you've done this research work, it will be easy appeal to get employed by these providers. Right? Another thing is that any questions, comments? Is anything possible with serverless computing? This is not a difficult question. Suppose you have some application that can be modularized, but not all of the modules in your code maybe or may not, not everything might be available as a function, as a service from the cloud provider, right? Web server, what do you think? It's already there. You have used it before for assignment 2. So for a cloud provider's perspective, something very popular, well known, they will make it as a function already built, right? And then you can use our function. But whatever newer type of one, that's something you have to, I mean, it may not be available. So function as a service, it's not like an alternative to a container or virtual machine. What about the flexibility? What do you think? Convenience for well-known modules, serverless computing, probably the best, right? Flexibility, the lower, the better, right? Container is all great, but you are limited by the OS. So virtual machine is the one that has entire machine freedom. Yeah, looking at the evolution, we can see that bare metal, virtual machine, container, and now functions. These are function codes. For you, if you look at this symbol, oh, this is like a HTML code. Like for other non-tech folks, maybe your parents, why do they have this sign? You understand those. I'm not sure whether it's a good thing or not. All these function services provided by computer scientists, engineers. So it's a good way to illustrate the concept, but may not be always easy to appeal to regular users. Decreasing concern and control over stack implementation, increasing focus on business logic. Business logic, as you mentioned, here's an event, here's a database trigger, here's another processing trigger, things like that, right? But this is you can also say that you can have this is a decreasing concern and control, right? That means that this is the lower control you have. You don't have a concern much for the control because you don't have a control, right? So here, less concern, less control. Cons and pros. We have just 5 minutes left, so we can revisit this quickly last time, but you can see that this class, I've been glorifying serverless computing. Isn't it amazing? But at the end, I also said that there are limitations, right? So any technology, any concept you learn, first you want to appreciate the concept, understand the concept, appreciate the concept, but also I always want you to have a critical perspective as well. When is it good? When it's not good? Is it really good for everything? I want you to think about it. Now, even internet packet switching, circuit switching, the packet switching, the one that made the internet possible, data network, right? Still, it's not a slam dunk winner. There are cases that circuit switching could be better, but because of the nature of the usage of the internet data traffic that is bursty, in most of the cases, packet switching is better, but there are limitations, right? So that's the whole picture I want you to have. Okay, so I'll give you some time to take the exam, not the exam, quiz. So this is the quiz. Access code is W7. I eliminated the IP filter because I didn't know exact the prefix. It's due 11:20, so you have like 10 minutes. And always the latest one first. I will allow. Okay, so with that, thanks, and I will see you on Thursday.